manufacturing.
Yeah, thanks a lot. Idea is to give you a little bit of an idea about an application space for cybersecurity that is maybe not that well known, that for a couple of purposes is a little bit specific, or at least not easy accessible for a lot of people. I'm more trying to give you a high-level introduction. What are the parts that make it so specific? If you look up what is actually a manufacturing system, that's kind of the textbook image that you get, and you get those nice keywords. And to be honest, I don't took them from a textbook. They're from a company that sells smart manufacturing systems. They use IoT. IIoT is industrial IoT. That's essentially, instead of using a Raspberry Pi, we use a RAC one. Big data. We have autonomous robots, cloud computing. Everybody is doing AI and machine learning these days, of course. Fast network connectivity, edge computing. So I guess that's also a couple of Raspberry Pis. Simulation, digital twin. I will get back to that a little bit later shortly. And additive manufacturing, which in layperson's terms is 3D printing. So everything looks very modern. And I think for each of those individual topics, we had either this year at B-Sides or last year at B-Sides a talk how to secure them. So I'm done. We can start with the Q&A part. Not really. Let's have a look how the reality looks like. When they talk about automation, they talk about those type of devices. These are program and logic controllers, or PLCs. They exist essentially at least since the 70s, 1970s. They're rather stupid things, large relays essentially with a little bit of logic that can switch on and off heavy machinery. Very simplified terms. But these days they also have a nice display. You can see here LAN, they have a network connection. But they still need to talk also to all the other systems in there. We have SCADA systems, so control and data acquisition systems, usually for controlling some manufacturing systems or chemical plants, like here on the screen. We have ERP systems, so classical enterprise systems. Screenshot from a very widely used piece of software. Essentially UIs over glorified databases, and logic that tries then to implement processes on top of that, mostly for knowing where do you have your resources, do you need to order new stuff, and on top then systems that drive the actual manufacturing, where you have the instructions how to build actually physical stuff. So quite a number of different systems, which leads then in fact not to some nice modern system, but to a very complex and usually very heterogeneous software architecture. So this is essentially a reference software architecture. So not this is real life how it looks like. This is how essentially a well-designed system looks like in that space. Proposed by one of the companies that builds a lot of components in those systems, in particular ERP systems. SAP is also building manufacturing suites, so the other part of top, but not doing that SCADA and PLC stuff. And that's all very complex pieces of software that communicate over a large number of different protocols, some of them based or at least wrapped within TCP/IP, some of them using different protocols, and essentially all of them designed at a time where nobody could imagine that you connect such a system to something like the public internet. To give you an idea about the importance of those systems, the statistics that I was able to find, and it's really hard to find really concrete information in that space because the companies don't want to reveal it, is that's from the US. The average automotive manufacturer loses round about $22,000 per minute if one of their production facilities stops. So think about what that means in terms of, oh, I need to shut down those systems for a couple of hours for doing an upgrade. The salary for the people doing the upgrade becomes negligible, essentially. And those systems operate for a very long time. That's one of the things that is completely different to most of the more common security topics, web security, traditional application security. So SAP ERP 6 was released in 2005, so 20 years ago, and will still be supported for another 5 years. So think about, you write software now, essentially you have to live with the bugs of that software pretty much to more than half of your career. And that's not uncommon. The Siemens SPS, which is something like one of those PLC systems, they on average are being sold for 12 years and 10 years additionally then guaranteed spare part availability, so you still get the physical components if there's some defect, and of course you get software patches at least for security issues. So we are talking also about 22 years of support, and that's the support that essentially every customer can buy for a reasonable amount of money. At least in the SAP case, I know that there are then also special customers that do individual deals to extend the support for them by another number of years, and I'm sure Siemens is doing the same. I know that Microsoft is offering also individual support contracts. But then if we go down the line to the more what we know as an end consumer type of software, Windows Embedded or Windows IoT, how the earlier versions were called, so not the Windows version that we run on our desktop PCs or on servers. This is a special stripped-down version of Windows for embedded configurations with super extra long support life cycles. Is supported for 15 years. Now let's get to something that maybe many of you will also still consider to be a rather old technology. Java is a programming language, and that is a language that is being used a lot in this application area. The long-term support releases, the LTS releases, are supported for around 8 years. And then I tried to find out what is the support life cycle for web browsers, because of course all those systems these days are using web applications as the final end user interface. I haven't found any information for Chrome or Safari. Firefox has extended support life releases where they state, and I quote, more than a year. I guess that means 366 days on average. Definitely not 10 years. I looked them up for the last couple of releases. They were in the range of 14 months plus minus. So we're talking about a year to 1.5 years. And now think about securing such a system where 2005, which UI technology was modern at that time for web front ends, if you wanted to do a little bit more interactive development. Who remembers Flash, Silverlight? If you operate such a system, essentially, you kind of bought the right to use that until 2030. Neither Adobe, in the case of Flash, nor Microsoft, in the case of Silverlight, really want to be associated with those technologies anymore. That gives a very interesting space in terms of securing those systems, and also if you go into such a system landscape as a penetration tester, the knowledge that you need to have in terms of the technology stack. Archaeology is part of the business, essentially. And we can see the problem that, core technologies the systems are using or built upon are way less or shorter time frame supported by their manufacturers than what the enterprise systems promise and guarantee their customers, not only promise, they actually guarantee it. And I can, for example, confirm that since Java is open source, SAP is essentially maintaining a fork of old Java versions that then matches their support promises, which is quite an additional effort. Let's have a look at a couple of example attacks that we have in that space. This is a message that one of the largest aluminum companies, Morse Hydro, got. Don't need to read all the details. I guess it's also one that you guess the idea very quickly. There was a significant flaw in the security system of your company. You should be thankful that the flaw was exploited by serious people and not some rookies. Maybe they mind trustworthy, or that is a form of responsible disclosure. I don't know. But essentially, we encrypt your data with RSA and AES, and without getting the keys from us, you don't get access to your data. And that means also in the case of such manufacturing systems that usually configuration files, databases that the manufacturing systems are accessing are being encrypted. And that means that production is in still stand. And as said, I don't have data for aluminum production, but for the car industry, we've seen costs of those $22,000 US per minute. So if you then suddenly recognize that your production stands still, you get such an email that definitely gets your attention. And what happened here? In December 2018, the hackers weaponized an email. So essentially, they crafted a phishing email with a special attachment, really well done in the context of a legitimate communication between an employee at Norsk Hydro and I think it was a supplier or a customer of Norsk Hydro. That payload installed a Trojan on the employee's PC, so nothing special there. The antivirus software detected that Trojan and quarantined it within a couple of days, but sadly that was too late. Those couple of days, most likely only a couple of hours, if at all, given how well the first step was prepared, were sufficient for that attacking group for getting control over that PC, move laterally within the infrastructure, and over time gaining admin privileges, which meant they could then really encrypt a large amount of data, which they essentially did then around March 18th, 19th. This is where the company recognized that attack because the production stopped due to the encrypted data. And we can see from December to March, so we are talking about around about 4 months, where the attacker were in the system with security patches installed and antivirus software being installed. Interesting here, maybe from a broader perspective, the company had a super open communication process, what was going on with regular press updates as well, and interviews they gave, and they refused to pay any ransom. And the estimated damage for the company is more than 45 million British pound. But as I said, essentially, this is one of the examples where we don't see any special attacks really on the manufacturing systems. This is also an interesting one from a slightly different perspective. Reads first, very much standard. In May 2016, the US Department of Homeland Security released a CERT alert based on actual exploitations going on and compromise of unsecured internet-facing SAP applications. And one vulnerability, in particular a CVE, was highlighted in that alert, and that CVE was the CVE 2010-5326. And for those of you you that know how CVE numbers are being assigned, there is already something interesting going on. CVE 2010 means that CVE has been assigned and the vulnerability has been discovered and known publicly in 2010. So if we assume that that happened in December 2010, we are still talking about nearly 5.5 years in which that publication was known to the public. And usually those CVEs are also only published after patches have been made available. A patch has been made available, was available when the CVE was published. I checked that. So we have here the situation of a critical patch, and this patch was classified as critical, which at that point in time in 2010, SAP wasn't using CVSS scores, which most of you might know, which is a standard way of measuring the criticality of vulnerabilities. They use their own system, and critical is the highest category in that system. And essentially that means if you don't install security patches closing critical security vulnerabilities, on paper you lose the support for the system that you're operating. So the support contract essentially obliges customers to install patches for such critical vulnerabilities. And if the US Department of Homeland Security is involved, we might also speculate that the customers affected by this vulnerability weren't some private sector companies. It's very likely that that were some government organizations where we usually assume that they have a very high security standard. So even those are not able to prioritize patching in the right way and install patches within 5 years. For consumer hardware, we don't even get patches for that long, and we essentially cannot operate systems for that long. They have patches and are not installing them. And most of you have heard about this one here, Stuxnet. This is a state-sponsored attack, or it's believed at least to be state-sponsored, on Iranian facilities for processing atomic material. And essentially, that has a very long kill chain. And here, the interesting part is, so it starts with essentially standard application security stuff. Here, also with a USB stick that was distributed, and essentially hoping that some employee puts in that USB stick into their machine, then exploiting a couple of vulnerabilities, including one in the printing system of Windows, but then getting access and only being active when they were on a system connected to a very specific SCADA system provided by Siemens that essentially is only used in this kind of facility. So that was a super targeted attack, which is one of the evidences that it was most likely state-sponsored. And then this then makes it here really interesting in the manufacturing area. It really was an attack exploiting a vulnerability on those SCADA systems, and then also showing to the operator. So if I go back, can think about a SCADA system as one of those systems where you have your physical processes running on your factory floor, maybe secured, maybe it's not even safe for humans to be next to them, and you have your screen with all the valve pressures and which valves are open and which ones are closed to control that system. And essentially they discoupled the display here with the physical system, and while the physical system was running into a critical condition that essentially destroyed the system, everything looked nicely and well for the operator. But this is essentially the attacks that we know about on those systems. And except for the last one, none of them is really manufacturing specific in terms of the systems that are being attacked. A couple of years later, in 2017, There was also an attack on a Middle East petrochemical facility. This also similar specific, also attacking a very specific industrial control system. This time one from Schneider SE, which is a French company, most likely also state-sponsored. So based on the publicly known attacks, the exploit vulnerabilities are usually in rather old systems. Essentially when the systems that are being attacked were developed under the assumption that they run in an air-gapped environment. No direct connection, in-network connection to public-facing networks. Criminal gangs seem to focus on ransomware, using more traditional kill chains, and to a certain extent, the shutdown of a production system is happening by accident. They would most likely be similarly happy if they just encrypt the financial data or the planning for the next year, or similar operation critical data. But of course, stopping production is for them a nice benefit. Suspected state-sponsored attacks are on a different field. They really try to attack very specific systems. Okay. Now, what is the elephant in the room here? We have all those enterprise systems essentially implementing business processes. And we know business process logic faults. That's also a fault category for web applications. And the most famous one, the standard example, so to speak, is the shopping cart web application that, for example, has a bug in the process implementation and might allow a customer to cancel the credit card payment that is usually done in an external system and still confirm the payment and the goods are being shipped without payment. We call that a business logic vulnerability because the buggy thing, the thing that has the vulnerability, is the actual business process being executed. And not many people look into those. That's already a problem. And now we have those old systems, and we have way more complex business processes than only operating a shopping cart. So what about those? That's actually a problem as well. And that's currently a rather hot research topic as well. And there are a lot of different impacts that you can have as an attacker when you try to attack those processes. You have things like there might be actions on a good that you are producing that are non-reversible. You execute them, and if you do that wrongly, you can throw that product into the trash and no longer use it. There's no way of repairing it, or it might delay the process a lot. If you send it to the wrong production plant, it might be not available for 3 weeks, which happens then results in a long standstill. You have those digital twins, where essentially that's marketing speak for I have my physical goods and I have a digital model on it, and I operate on the digital model and expect similar effects then to happen on the physical model as well. If they get out of sync, your quality control is no longer working and you run into problems. So you have all those kind of things. And I explained that essentially already. That gives a lot of problems when you need to achieve the positive effects of them. So you don't want non-reversible actions in your systems, at least for large parts. You want to have timing constraints to being adhered to. You want to have being aware of the provenance of goods that you produce and ship. And an attacker can willingly, of course, try to infiltrate that and invalidate those constraints. And that's exactly what people are trying to do. The only problem is we are not aware of that. Not because the companies are not necessarily aware of that. Of course, if the production goes into a standstill, we learn about that. but usually companies don't have a big interest in making that public. We mostly learn about the situations where there is no way of hiding it. So in some countries, there are legal requirements to publish such attacks. Or if it's end consumer goods, if a car production goes down, cars are delivered to end consumers, everybody recognizes. If they have to wait for their car suddenly a couple of weeks longer than promised. And the other challenge here is a lot of the requirements, the things that we need to protect our systems against are specified in informal documents. Processes are not all digitalized, so sometimes the tracking of goods is done by QR codes that you need to secure as well or model securely. So a lot of new additional challenges and data sources that we usually don't have in traditional web applications. And that's not a completely academic thought of problem. As I said, we've seen a couple of those issues happening, but not well documented, because usually, again, those attacks are not being documented for the public. We have I have one reference, but also don't know the details, to be honest. That was in an aircraft manufacturing system for a US military jet, where a business process flaw resulted in the fact that in one part of the manufacturing chain in a different factory, essentially that part believed that there are no airframes available, and that started to order more and more new airframes. And in the other one, they were producing them, but they were not collected. And that resulted in a shutdown for 2 weeks, essentially, and that nice quote of the VP of manufacturing that airframes were stacking up like cordwood. They are not small. One would expect that somebody recognizes that, but that results really in expensive attack vectors. And it's not only those kind of obvious things. There are a lot of new threats that we need to think about. In a project that we are currently working on, we are looking at those kind of issues, and one of the use cases is aircraft manufacturing. And you have suddenly attack vectors like torquing an individual screw, because if you do that wrongly, that aircraft might crash. This is a safety alert from the National Transportation Safety Board. That's essentially the organization in the US that investigates every crash of an aircraft, regardless if it's an autonomous one or one with passengers, or a cargo plane. Essentially evidence and recording that there's one screw in the aircraft engine. If that is not being torqued correctly, that aircraft is likely to crash. And if something like that happens, somebody doing a mistake or an attacker, for example, modifying the instructions for the person torquing that screw, the impact on the real life is pretty severe. And that's a research where we are working on, where we're trying, and this is an old prototype. The current prototype that we have is mostly command line based. That doesn't look like that nice on slides. The UI is something to be developed at later stages, but essentially trying to extract the information from real world systems. And I know this is the red track. I still rather sell it in the way that the tool allows companies operating those systems to find the vulnerabilities, to fix them before somebody else does. But we all know that those kind of security tools are, of course, always on the fence of being used in both areas, or at least potentially can be used by people with different intention. So we're trying to extract the information, extract the processes that are running on, and looking then for areas where requirements are not being satisfied, or where small changes result in a severe impact. This is here, for example, a very small process where people can improve their own work. Things that we also seen in some manufacturing scenarios. If if you read the press, where people essentially did their own quality inspection. And this is something that we can detect with a tool and then also visualize to an auditor or to a security expert looking at those kind of issues, or here even to a safety person, that look, if you run that process as here, specified or implemented in the system, the person doing the work can also improve and do their own quality check. That's most likely not a thing that you want to happen. Or checking that high-level requirements that you have extracted from the processes even are also propagated into the actual source code of the implementation and report violations there as well. That's all from my side. Timing works nicely because I wanted to have time for Q&A. The thing that I didn't tell, and I thought about putting it into the motivation, but I thought it's also nice to have it as a hindsight. Since 2021, in the yearly X-Force threat report from IBM, manufacturing is the most attacked business sector. It overtook finances. Nevertheless, we hardly hear anything about cyber attacks on manufacturing. And that's a little bit essentially the part of the motivation for the talk, to raise awareness of that problem. As usual, when designing systems, and that holds essentially for all systems that we are designing or processes, we should not only focus on the expected behavior, so the positive outcome, but also what are the things that we don't want the system to do, even if somebody is trying to push the limits and force the system to do it. What holds for business logic vulnerabilities, and that's often something that maybe results in deprioritizing them a little bit. They are usually vulnerabilities that need an authenticated user. So they are often put down as, yeah, but you need to have an account that's an insider. Yes, that's on the one hand true. On the other hand, in particular in the manufacturing scenarios, the impact that they have are severe. They are life-threatening in many situations. We are no longer talking about, oh yeah, we are leaking a little bit of data that might be annoying for people. It's really life-threatening in the original sense of the word. If you think about, for example, a crashing aircraft or an exploding chemical plant. So we really need to be careful with assessing the risk when looking at impact and likelihood, and think about, yep, but if somebody somehow overcomes the first authentication barrier, or maybe is an actual insider, if the attack is interesting enough to bring somebody into the system, then we need to think about the impact a little bit more careful as usual. It's all from my side. Happy to take questions. Yep.
Do you think, it seems surprising to me that there haven't actually been more attacks similar to Stuxnet, if it's such a popular sector?
The Q&A is not recorded, right?